To keep in some of the heat, we could close all doors and windows, not leave them open. And also we could put insulation around everywhere to keep in heat and draft. Keep out draft. And not put on the lights unless it gets very dark.
I think that lagging and insulation on any pipes that are around the school should be done, because although it will cost quite a lot of money to do this, as for any lagging that hasn't been done, and any that's fading that needs renewing, in the long run, after a while, it will pay back itself in the heat energy that it saves. So this will save the school quite a lot of money.
Presenting an account of work done to the class can also be partial technology, so also can writing stories. For example, writing a story from the point of view of some potatoes that were cooked and showed heat transfer, as in Module D2. Another partial technology involves starting from a relevant practical context.
Salter's chemistry is a Mode 1 chemistry syllabus, but we ought to look back about 8 or 9 years to see where it came from. And it came from a group of us who were deeply concerned about what was happening to chemistry teaching in schools for 2 reasons. One was that chemistry was becoming conceptually more and more difficult at O-level and CSE. That was a worrying sign. And the other was that there was a development of balanced science, which we saw was taking off. And we were very worried about the place of chemistry in that.
I chose Salter's chemistry because I've been teaching traditional chemistry for 7 years, and a lot of children had been asking me, why do we do this bit, miss? And they were finding it hard. The concepts were difficult, very abstract. The children had no experience of what we were talking about. They couldn't relate to what we were talking about. And I was finding it harder to justify.
During the writing workshops, instead of doing the usual way of developing curriculum, where you define what people ought to know when they're 16, and then devise materials in order to achieve those ends, we kept asking ourselves the question, what is it, in what ways does chemistry contribute towards the lives of 13-year-olds? In what ways can chemistry help them to understand the environment in which they live?
The approach that was taken in Salter's chemistry meant that we included a number of topics which are not commonly encountered in chemistry courses. That meant that a lot of thought was given to the sort of activities which would be going on in the classroom. And because we had some very creative and adventurous teachers on the team, we developed a wide range of activities, extending to role plays and dealing with open-ended issues of a sort that you might not commonly find in a chemistry course.
I don't think it's important that it's not pure chemistry. I think a purist would find it quite a difficult course to teach. But the fact that we trespass into other subjects, I think, is a good thing.
We haven't published a hardbound book. We have a book which can be torn apart so that each department can look at that material and design their own course from them. They can make amendments and changes in order to suit the ability range of the pupils in their particular classes.
Well, to begin with, the children were thinking about fabrics, and this lesson has come at the end of looking at a whole unit on fabrics and clothing. And to finish it off the section, we've been looking at how we could change the properties of materials. Some of them were dyeing the fabrics, and some were flame-proofing, some were waterproofing.
Then you put like the sheet on the top.
So after we've introduced the subject, the children would begin to plan their investigation. I would expect them to start thinking of some tests to compare the treated material with the untreated material. Once they've checked their investigation with me, then I'll let them go ahead with it if it's safe, even if I think it may not work.
Squirt a bit more on.
We'll do the polyester first.
Yeah, one. It's still burning.
8 seconds. to get the tongs and put them in that beaker.
Right.
Once the investigation is over, then they will sit down together and plan a report, which I expect them to give to the rest of the class.
We had 3 different types of material. We had polyester, nylon, cotton, and we had 2 pieces of each of these. And we snipped a small rectangle out of 1 piece of each, and we set them alight, and we made a note of how they caught fire and timed how long it took. And then we took the other 3 and we put them in borax solution, and we soaked it for 10 minutes. And then we put it in an oven until it was dry, and afterwards we set them alight to test if they were fireproof.
Before the materials were untreated, the polyester shriveled up and it took about 15 seconds to burn. And the cotton disintegrated after about 30 seconds. And the nylon flared up and took about 10 seconds to burn. And after they were treated, the polyester burned, but it burned more slowly. And the cotton burned, but it burnt more slowly and just didn't disintegrate. And the nylon only took about 8 seconds and shriveled up. So that means that fireproofing doesn't stop things burning, it just slows down the process of burning. So if it was used in a theatre, the actors and the audience would have more time of getting out.